Why are so many people eating more protein or more muscle-building foods and yet still losing strength as they age? Why do we see people in their 50s and 60s get steadily weaker, struggle with mobility, and end up with frailty even though they've tried everything from exercise to supplements? Here's what's really going on inside your body. Behind every loss of muscle, what doctors call sarcopenia, is a constellation of root causes: chronic low-grade inflammation, insulin resistance, mitochondrial dysfunction, hormonal shifts, and inadequate anabolic signaling in muscle tissue. You can eat a steak every day and still lose muscle if those pathways are blocked. In this talk, I will show you that it is not about sardines or any single superfood. The real secret is a food, or class of foods, that you may already know, but with a new lens: how it triggers muscle protein synthesis, how it overcomes anabolic resistance, and how the right timing, context, and co-nutrients make it far more powerful than you imagine. By the end of this, you will have 6 science-backed insights, not fluff, each with actionable protocols you can apply tomorrow. You will understand not only what to eat, but why it works at the physiological level, and how to structure your day: meals, fasting, training, recovery, so your body actually builds muscle instead of breaking it down. In brief, here is what we will cover. Number 1, why sarcopenia is not inevitable and how anabolic resistance sets in with age, but can be reversed. Number 2, how a meal threshold of essential amino acids, especially leucine, serves as the trigger for muscle protein synthesis, and how that threshold changes with age. Number 3, why the worst mistake is uneven protein distribution, i.e., protein loading all in dinner, and how spreading protein across meals unlocks a continuous anabolic state. Number 4, the role of insulin sensitivity, mitochondrial health, and inflammation in turning your body into a muscle-building environment. Number 5, specific food choices, co-nutrients, and synergistic compounds, e.g., creatine, HMB, omega-3s, vitamin D, that amplify your muscle-building potential. Number 6, the timing of meals, resistance training, and fasting windows, and how to align them to beat muscle loss and maximize gains. I will tell you stories of real people who reversed muscle decline by applying these steps, and I will draw whiteboard analogies so that the biochemistry is simple and vivid, not intimidating. If so far this feels helpful, please subscribe to the channel. My goal is to bring you actionable, science-driven health tools every week. Here is a truth that changes everything. Most people believe muscle loss is simply an unavoidable part of aging, like gray hair or wrinkles. But what the research shows is that the real enemy is not age itself. It is a metabolic condition called anabolic resistance, where your muscles stop responding to the very signals that tell them to grow. Imagine your muscles as a factory. In your 20s, that factory is open 24 hours a day, producing strong, healthy fibers every time you eat protein or lift weights. But as you move into your 50s and beyond, that factory does not close, it just becomes less responsive. The machinery is still there, but the workers are sluggish. The raw materials pile up at the door, and production slows. That sluggishness is anabolic resistance. So what causes this slowdown? Scientists now point to 4 major disruptors inside the body. Number 1, insulin resistance. When your muscle cells no longer respond well to insulin, they cannot efficiently pull in amino acids, the building blocks of protein. Even if you eat plenty of protein, it sits in your bloodstream instead of entering your muscle tissue where it belongs. Number 2, chronic inflammation. Low-grade inflammation, often driven by processed foods, poor sleep, and visceral fat, interferes with the chemical signals such as mTOR and IGF-1 that trigger muscle synthesis. Inflammation acts like static on a radio. It blurs the message your body is trying to send. Number 3, mitochondrial decline. Your mitochondria, the power plants inside your cells, are responsible for turning nutrients into usable energy. As they weaken, so does your muscle's ability to repair and grow. This is why energy levels drop, recovery slows, and fatigue sets in. Number 4, hormonal shifts, declines in testosterone, estrogen, and growth hormone can lower protein synthesis and reduce the regenerative potential of muscle cells. Now, here is the good news: every one of these factors is reversible. Studies from the National Institute on Aging and the Journal of Cachexia, Sarcopenia, and Muscle have shown that with the right nutritional and metabolic interventions, older adults can regain anabolic sensitivity comparable to that of much younger individuals. Let me explain this with a simple analogy. Think of your muscle like a sponge. When you are young, that sponge is dry and ready to soak up every drop of protein you feed it. But with time, that sponge becomes stiff and saturated. It does not absorb well. The way to make it responsive again is not to pour more protein on it, but to wring it out, that is, to reset the internal environment by improving insulin sensitivity, lowering inflammation, and restoring mitochondrial function. So how do we wring out the sponge? First, reduce refined carbohydrates and processed seed oils that drive inflammation and insulin spikes. Focus instead on whole food fats like olive oil, avocados, nuts, and fatty fish. Second, engage in resistance training at least 3 times per week. Lifting weights or using body weight exercises sends a mechanical signal that wakes up dormant muscle fibers and reactivates the mTOR pathway, the same pathway that tells your body to build. Third, integrate short fasting windows, such as 16 hours of fasting and 8 hours of eating. Intermittent fasting improves insulin sensitivity and triggers autophagy, the process that clears damaged mitochondria and old proteins, essentially rejuvenating your cellular machinery. And fourth, ensure every meal contains a complete source of protein, not just in grams, but in leucine content, which we will discuss in the next section. In the next section, we will dive into the secret amino acid that acts as your body's muscle switch and why missing it by just a few grams can make all the difference. Here is where things get very practical. Most people think that if they simply eat enough protein, their body will automatically build muscle. But what the research shows is that the signal to build muscle is not turned on by total protein alone. It is turned on by a single amino acid called leucine. Leucine acts as the ignition key for your muscle-building machinery. Without enough of it in one meal, that machinery never starts, no matter how much total protein you eat throughout the day. Let me explain this with a simple analogy. Think of muscle protein synthesis like starting a car. Protein provides the fuel, but leucine is the key in the ignition. You can fill the tank completely, but if you never turn the key, the car will not move. Scientific studies, including a 2024 review published in Frontiers in Nutrition, have shown that leucine activates a molecular pathway in your muscle called mTOR, short for mechanistic target of rapamycin. This pathway is the master switch that controls muscle repair, recovery, and growth. When leucine levels in your bloodstream reach a specific threshold, typically between 2.5 to 3 grams in one meal, mTOR turns on and your body begins synthesizing new muscle proteins. Here is the challenge. As we age, our leucine threshold rises. A younger person in their 20s might only need about 2 grams of leucine to activate mTOR, but someone in their 60s might need closer to 3.5 grams. This means that many older adults who believe they are eating enough protein are never actually crossing that activation line. Let us put that into real-world terms. To reach the leucine threshold, you would need approximately about 30 to 35 grams of protein from high-quality sources such as eggs, chicken, beef, or fish. Around 40 grams of protein from plant-based sources like lentils, quinoa, or beans, because they contain less leucine per gram. This is why a breakfast of oatmeal with a splash of milk might provide 10 grams of protein, but not nearly enough leucine to trigger muscle growth. Yet, a breakfast with 3 eggs and a serving of Greek yogurt could easily hit the leucine threshold and turn on your body's anabolic switch. Here is another key insight. Leucine works best in the context of balanced insulin sensitivity. Insulin is the delivery system that helps amino acids enter your muscle cells. If insulin resistance is present, leucine cannot do its job effectively. That is why repairing insulin sensitivity through fasting, lower sugar intake, and resistance exercise magnifies leucine's impact dramatically. So what are the best leucine-rich foods? According to a 2024 meta-analysis in the Journal of Nutrition and Metabolism, The top whole food sources include beef, chicken, tuna, eggs, dairy, especially whey and Greek yogurt, and certain plant-based options like soy and pea protein. Interestingly, cottage cheese was shown to sustain leucine availability longer due to its slow digestion, making it a powerful nighttime option for muscle preservation. You can also find targeted leucine supplements or essential amino acid blends, but for most people, whole foods are sufficient when the meal is properly structured. Here is a simple daily framework. Breakfast: 3 eggs, 1 cup of Greek yogurt, and a handful of nuts. Lunch: 4 ounces of chicken or tofu with vegetables and olive oil. Dinner: 6 ounces of salmon or beef with leafy greens and avocado. Each of these meals should reach the leucine threshold and stimulate muscle protein synthesis at least 3 times per day, morning, midday, and evening. This keeps your body in a consistent anabolic rhythm rather than a catabolic one. In short, leucine is not just another amino acid. It is the biological signal your body listens to. Cross that threshold, and you tell your cells, build. Miss it, and no matter how much protein you eat, the signal stays silent. In the next section, we will explore the distribution principle, why spreading protein evenly across your meals, rather than loading it all at dinner, is the hidden key to maintaining muscle throughout the day. Here is a mistake almost everyone makes, and it silently erases the benefits of even the best diet. Most people eat very little protein early in the day, then load nearly all of it into one large dinner. On paper, their total daily protein might look perfect, but inside their body, the muscle-building machinery only switches on once at night. Your muscles do not work on a daily total. They work on meal-by-meal signals. Each time you hit that leucine threshold we discussed earlier, you trigger a wave of muscle protein synthesis, the process that repairs and rebuilds your muscle fibers. But if that trigger only happens once in 24 hours, you spend most of your day in a catabolic state, breaking down muscle instead of building it. Here is a simple analogy. Imagine your muscles as a house under renovation. The construction crew shows up only when they receive a signal, in this case, leucine from protein intake. If you send the crew to work once a day, the house gets minimal progress. But if you call them in 3 times a day, each shift gets something done, and your house, your muscle, steadily rebuilds. Several recent studies support this pattern. A 2023 study published in the American Journal of Clinical Nutrition found that older adults who consumed protein evenly across 3 meals had significantly greater muscle protein synthesis compared to those who ate the same total protein mostly at dinner. Another trial from Nutrients in 2024 confirmed that balanced protein distribution improved both muscle mass and strength after just 12 weeks, even without changing total calorie intake. The science is clear. Frequency matters just as much as quantity. Your goal is to stimulate muscle protein synthesis 3 times a day, every 4 to 5 hours, using meals that each hit the leucine threshold. Here is what this might look like in practice. Breakfast. Morning anabolic trigger. A high-protein start sets the tone for the day. Think of 3 to 4 eggs with Greek yogurt or a whey protein smoothie blended with almond butter. This immediately wakes up your metabolism and begins the repair process after the overnight fast. Lunch, midday maintenance. About 4 to 6 ounces of chicken, fish, or tofu, combined with a moderate serving of carbohydrates like quinoa or sweet potato to help shuttle amino acids into muscle tissue. Dinner, evening recovery. A slower digesting protein such as cottage cheese, lean beef, or salmon. This supports overnight repair, especially when combined with omega-3 fats to reduce inflammation. Now let us talk about something subtle but powerful, the anabolic window myth. Many believe you must eat protein immediately after a workout or the opportunity is lost. The truth is, your muscle protein synthesis stays elevated for up to 24 hours after resistance training. What matters most is not the exact minute you eat, but whether your total day includes multiple leucine-triggering meals within that time frame. However, there is one exception. If you train in the morning after fasting, having a protein-rich meal or shake shortly afterward can help replenish amino acids faster, ensuring your muscles have the raw materials they need to rebuild. Here is the physiological reason all this timing matters. After about 4 hours, your body shifts from an anabolic to a catabolic state, from building up to breaking down. By reactivating mTOR through properly timed meals, you keep your muscles in a positive protein balance. Over weeks and months, this cumulative effect translates into noticeable differences in muscle mass, energy, and strength. Now combine this meal timing rhythm with regular resistance training, and you have a metabolic environment that favors muscle retention rather than loss, even well into your 70s. So remember this principle. Protein timing is not about eating more, it is about eating smarter. Spread your protein evenly, cross that leucine threshold at each meal, and you transform your body from a slow-building house into a 24-hour construction zone for muscle repair and growth. In the next section, we are going deeper into the metabolic side of the equation, how insulin sensitivity, mitochondrial function, and inflammation dictate whether your food becomes fuel for muscle or stored as fat. Here is where muscle meets metabolism. Most people think building muscle is just about lifting weights and eating protein, but your ability to build and preserve muscle depends heavily on what is happening deep inside your cells, specifically how sensitive your body is to insulin and how strong your mitochondria are. Let me explain this with a simple image. Imagine your muscle cell as a factory with two departments. One department receives raw materials, amino acids, glucose, and nutrients through insulin. The other department, the mitochondria, turn those materials into usable energy. When both departments work efficiently, the factory thrives, energy flows, repairs happen, and new muscle tissue forms. But if insulin resistance develops or the mitochondria begin to fail, that factory slows down, the doors jam, the lights flicker, and production stops. This is exactly what happens inside aging or metabolically unhealthy muscles. The food you eat no longer translates into energy or growth. Instead, it spills over into fat storage and inflammation. Let us start with insulin sensitivity. Insulin is not just about blood sugar. It is a master signaling hormone that tells your muscles to take in nutrients. When you eat protein or carbohydrates, insulin helps shuttle those amino acids and glucose into your muscle cells. But if you have insulin resistance often from years of high sugar intake, refined carbohydrates, and sedentary behavior, that signal weakens. Your muscles stop absorbing nutrients efficiently. So even if you eat a perfect meal, your body cannot use it properly. A study published in the Journal of Physiology in 2024 confirmed that improving insulin sensitivity through resistance training and intermittent fasting directly increased muscle protein synthesis in older adults. The takeaway: to rebuild muscle, you must first make your body responsive again. Now, let us look at the mitochondria, the tiny powerhouses that generate adenosine triphosphate, or ATP, your body's energy currency. Healthy mitochondria not only power your workouts, but also control the repair and regeneration of muscle tissue. When they are strong, your metabolism runs hot. When they are weak, fatigue sets in, and muscle atrophy accelerates. Chronic inflammation is the silent killer here. When inflammatory molecules like cytokines build up, they damage mitochondrial DNA and slow energy production. This is why people with metabolic syndrome, obesity, or fatty liver often experience muscle weakness and poor recovery. Their cells are literally energy-starved. So how do we fix this metabolic dysfunction? Number 1. Train your insulin sensitivity daily. You can do this through short, consistent bouts of resistance exercise. Even 10 minutes of bodyweight squats, push-ups, or light weightlifting increases glucose uptake in muscles and restores insulin responsiveness. Number 2. Cycle your energy intake. Incorporating short fasting windows, for example, 16 hours of fasting with an 8-hour eating window forces your body to burn stored fat, lower insulin levels, and activate a cellular repair process called autophagy. During this time, your cells remove damaged mitochondria and replace them with new ones. Number 3. Feed your mitochondria wisely. Nutrients such as coenzyme Q10, alpha-lipoic acid, L-carnitine, magnesium, and omega-3 fatty acids enhance mitochondrial function. Studies in nutrients and cell metabolism in 2023 showed that these compounds not only improve energy production, but also reduce markers of oxidative stress and inflammation. Number 4. Balance your carbohydrate intake. You do not need to go zero carbohydrate, but focus on the timing and quality. Whole, fibrous carbohydrates such as vegetables, lentils, and quinoa provide steady glucose without spiking insulin. Avoid refined grains and sugars, which impair insulin signaling and feed inflammation. When you combine these metabolic resets, your muscles become far more responsive. Protein and amino acids now enter cells more effectively. mTOR is activated more easily, and your body starts using food as fuel rather than storing it as fat. Think of this process like cleaning and oiling a machine. Once the gears are clean and the power supply is stable, every nutrient you consume works harder for you. Your training feels easier, recovery becomes faster, and energy becomes more stable. In essence, strong metabolism equals strong muscles. You cannot separate the two. In the next section, we will uncover the synergistic nutrients and compounds that amplify muscle growth, the nutritional allies that make every bite of protein count double in your favor. Now that you understand how muscle is built, fueled, and protected at the metabolic level, it is time to look at the supporting cast, the nutrients that make the process more efficient, more powerful, and more sustainable. Building muscle is not just about protein and calories. It is about creating a biochemical environment where every nutrient works in harmony to reduce inflammation, restore energy production, and accelerate repair. The right combination of micronutrients and cofactors can make the difference between simply maintaining muscle and truly rebuilding it. Let us begin with creatine, perhaps the most researched muscle-supporting compound in the world. Creatine acts as a phosphate donor inside your muscle cells, helping to regenerate ATP, the molecule that fuels every contraction. A 2024 meta-analysis published in the Journal of Strength and Conditioning Research confirmed that adults over 60 who supplemented with 3 to 5 grams of creatine daily gained significantly more muscle mass and strength during resistance training compared to those who did not supplement. Here is the key point. Creatine does not build muscle on its own. It enhances your ability to train harder and recover faster, which indirectly leads to greater muscle synthesis. It also increases water content within muscle cells, which acts as a hydration signal that promotes protein synthesis. Next, let us talk about omega-3 fatty acids, particularly EPA and DHA. These compounds, found in fatty fish such as salmon, mackerel, and sardines, or in algae-based supplements for those who prefer plant sources, have powerful anti-inflammatory effects. Chronic inflammation blocks mTOR and damages mitochondria, so reducing it is critical. Studies from the American Journal of Clinical Nutrition show that omega-3 supplementation enhances the muscle's anabolic response to both protein intake and resistance exercise, especially in older adults. Third, vitamin D plays a quiet but essential role. It functions as a hormone, influencing gene expression within muscle tissue. Low vitamin D levels are linked to reduced muscle strength, impaired recovery, and greater risk of falls in older adults. A 2024 review in Nutrients found that maintaining optimal vitamin D status, generally above 40 nanograms per milliliter, supports mitochondrial efficiency and enhances muscle contraction strength. The most effective way to increase it is regular sun exposure, or, if necessary, supplementation of 2,000 to 4,000 international units per day under medical supervision. Now consider HMB, short for beta-hydroxy beta-methylbutyrate. HMB is a metabolite of leucine that prevents muscle breakdown, especially during periods of fasting, illness, or caloric restriction. Research from Frontiers in Aging in 2023 showed that HMB supplementation helped older adults preserve lean body mass even without intense resistance training. It works by stabilizing cell membranes and reducing proteolysis, the breakdown of muscle proteins. Do not overlook magnesium, zinc, and selenium either. These minerals are crucial for energy production, muscle contraction, and antioxidant defense. Deficiencies are common, especially in those who eat a high-processed diet. Magnesium in particular supports hundreds of enzymatic reactions that involve ATP, while zinc helps regulate testosterone and repair tissue. Finally, there is a fascinating synergy between polyphenols, plant compounds found in berries, olive oil, turmeric, and green tea, and mitochondrial health. These compounds activate the AMPK pathway, a cellular energy sensor that improves fat metabolism and enhances mitochondrial efficiency. In simple terms, polyphenols keep your cellular engines clean, allowing better energy delivery to your muscles. So how can you apply all this? Here is a simple, evidence-based supplement and nutrition framework. Creatine monohydrate, 3 to 5 grams daily, taken with a meal. Omega-3 fatty acids, 1.5 to 2 grams combined EPA and DHA daily. Vitamin D3, 2,000 to 4,000 international units daily based on blood levels. HMB, 3 grams daily, divided into 2 or 3 doses. Magnesium, glycinate or malate form, 300 to 400 milligrams daily. Zinc and selenium, from whole food sources such as pumpkin seeds, seafood, and Brazil nuts. Polyphenol-rich foods, daily intake of berries, extra virgin olive oil, turmeric, or green tea. All these work synergistically, not individually. You are not trying to build muscle with a pill. You are creating an environment where every molecule in your body is aligned toward repair, growth, and metabolic balance. In the next section, we will pull all these pieces together into a complete daily blueprint, how to synchronize your nutrition, fasting, and resistance training to reverse sarcopenia and rebuild muscle no matter your age. Now that we have explored the science, let us turn it into a practical daily system, a blueprint that you can apply immediately. Because knowing how muscle is built is one thing. Training your body to actually do it every day is another. The secret is synchronization. Nutrition, fasting, and resistance training must work together like the gears of a clock. When they move in unison, the result is steady, powerful muscle growth and a metabolism that stays youthful for decades. Let us begin with training. Resistance training is the single most potent natural activator of mTOR and muscle protein synthesis. It sends a mechanical signal that tells your body, these muscles are still needed, do not break them down, rebuild them stronger. The key principle is not just lifting heavy weights, but creating progressive overload, gradually increasing the demand on your muscles over time. For example, frequency, 3 to 4 sessions per week. Duration, 40 to 60 minutes each session. Focus, large compound movements such as squats, lunges, push-ups, rows, and deadlifts. These exercises recruit multiple muscle groups, producing a far stronger anabolic signal. Intensity. The last 2 repetitions of each set should feel challenging but controlled. For those who are older or returning after a long break, bodyweight movements or resistance bands are excellent starting points. Studies published in the Journal of Aging and Physical Activity in 2024 confirm that even moderate intensity training, when done consistently, can rebuild lean mass and improve functional strength within 12 weeks. Now let us synchronize this with nutrition timing. Your muscles are most receptive to nutrients in the hours following training. This does not mean you must eat immediately after, but consuming a leucine-rich, balanced meal within 2 hours of finishing your workout enhances muscle protein synthesis significantly. For example, a post-training meal might include grilled salmon, vegetables, and a small portion of sweet potato or quinoa to replenish glycogen. Here is a simple daily rhythm for combining training, eating, and fasting. Option 1. Early training. Morning schedule. Break your fast after your workout with a protein-rich meal, for example, eggs and Greek yogurt. Eat a balanced lunch and dinner, each reaching the leucine threshold. Begin your overnight fast after dinner. Option 2. Midday or evening training. Afternoon schedule. Eat your first meal around midday, ensuring adequate protein. Train in the afternoon or early evening. Follow with a protein-rich dinner to support recovery. Fast overnight for 16 hours until the next day's midday meal. This intermittent fasting pattern, 16 hours fasting, 8 hours eating, works powerfully when combined with resistance training. During the fast, insulin levels drop, fat burning increases, and autophagy clears damaged cellular components. Then, when you break the fast with nutrient-dense foods, your muscles absorb those nutrients more efficiently.